Today we continue my descent into madness by looking at the Raspberry Pi 5 16GB and combining it with the Pironman 5, I think, case and asking the question, can a Raspberry Pi replace your desktop computer? When I was looking at different Raspberry Pi things, as you've seen over the last couple of videos, it dawned on me that I hadn't actually checked out the flagship Pi in quite a while, and specifically this version took my eye because it has 16GB of RAM. Quad-core processor, 16GB of RAM, that's sounding an awful lot like a pretty capable desktop computer. So naturally, I had to figure out, can we actually use it as a desktop computer? Is it more than just a tinker's toy now? And on its own, it's probably still a bit of a tinker's toy because at the end of the day, it has no good cooling. You have an SD card to boot from, which hasn't really got the best read and write speeds, and you're kind of limited a little bit by the I/O. However, this is something that I found online that I think could definitely fix that. It is a case, yes, with active cooling, good, but it also has an M.2 card slot, extra I/O, and generally I think could make a really great combination. So we're going to take a look at that, and we're going to do some benchmarking and answer the question of, can a Raspberry Pi actually replace a desktop computer in 2025? Briefly taking a look at the Pi itself, we've definitely come a long way from the kind of Raspberry Pi 2 that I would have last used. There is a lot going on here. Starting with that quad-core Cortex A76 processor. It's an ARM processor, 4 cores, running stock at 2.4 gigahertz. And of course, there's no cooling on this whatsoever. So I feel like thermal throttling will definitely be an issue here without some sort of cooling. On board, you've also got 16 gigabytes of LPDDR4X SD RAM. So plenty of RAM, pretty speedy. Yeah, definitely a big advancement over previous versions. You do have two of my least favorite ports in the world, micro HDMI ports. They are the spawn of Satan, but you do have two of them, so you can run two displays, 4K each, up to, which is pretty cool. Round the side, you've got two USB 2 ports, two USB 3 ports, and a gigabit LAN port. You do also have built-in Wi-Fi, which is a nice addition, and Bluetooth 5. Plus your usual pins and all sorts of other things for tinkering with. But most importantly, over here we have a PCIe lane basically available through this adapter port. It's a PCIe 2, I believe, 1X lane, so it's not the fastest thing in the world, but still, PCI support on the Pi. That's kind of cool. And yeah, that's what we're looking at here. So, you know, I think I'm probably the only person in the world that hasn't looked at this yet. But this isn't so much important. I want to have a look at the case as well. But first, let's do some benchmarking with our stock setup here. So I did a bit of benchmarking using the very sophisticated case of putting it on top of the box that it came in, which is just a cardboard box. It's good to see how little packaging there actually is. It's a great addition. So using that very sophisticated case, we obviously hit up a lot of thermal throttling. One thing that I do give them credit for is they will say that no damage can come to the Pi if you run it without active cooling. All that's going to happen is it's going to thermal throttle itself. So it's going to run slower, but it's not going to damage itself. It's going to keep itself at a reasonable temperature. And starting off with some synthetic benchmarks, we can definitely see that's the case with Geekbench. A single core score of 768 was achieved when I was testing it, with a multi-core score of 1400, which does immediately seem strange. There's 4 cores. You would expect roughly 4 times the multi-core performance to the single core. But what happens is when we hit all 4 of those cores, we really start to get that thermal throttling, and it kind of keeps itself at about 80 degrees. Which is definitely hot, but it's not going to cause any damages to the silicon. So you are just going to hit thermal throttling, and the result is a much lower multi-core performance than you might be able to achieve with active cooling. We're also kind of getting about a 50-degree idle, which again isn't particularly ideal. It's not going to cause any damage, but it's still producing quite a lot of heat. This is certainly a huge step up from previous Pis in terms of its heat output. And then a quick test of my SD card, which is a SanDisk Extreme micro SD card. And we were getting about 70 megabytes write speed and 90 megabytes read speed. Again, not particularly amazing. When you've actually got such a performance system as this, it's going to be a big bottleneck running stuff off that SD card, in my opinion. So I'm glad to see that we'll be able to replace that with a nice M.2 card instead. And loading up Minecraft, we can actually see that this is definitely where we're going to hit two issues. A, the thermal throttling, and B, the SD card being the read and write. It takes a long time for chunks to load in, and we are getting about 5 FPS while that's happening. Once the system calms down and things are smoother, we do get about 20 FPS and it becomes a bit more playable. But Minecraft is an incredibly CPU heavy and read-write heavy game, so we really start to suffer here. And I think it's a good stress test of this system that these are the key areas that are kind of problematic. Having said all that, this is an incredibly impressive little system, really, especially considering throughout my testing, the maximum energy draw that I was getting was about 11 watts of power, which is kind of crazy. That's, you know, a tenth of what my home server draws, and if I had 10 of these in a cluster, there would definitely be more power there, that's for sure, especially if we can enable some active cooling. So with that all said and done and some preliminary testing, let's take a look at this kind of case, and it's not just a case, the whole thing that it comes with, and let's get this built. We are going to look at the case next. Annoyingly, I've just recorded halfway through looking at the case and actually it wasn't recording. So we're going to go again, but let's actually start with the box itself, and then we'll go through the things that I've already removed from the box itself. This is our case, the Pironman 5 maybe? Not sure how we're going to pronounce that, but we're going to go with that. And come with this by SunFounder. Came from China. Did take maybe about 2 weeks for it to get here. Some of the features that it mentions, it is specifically only compatible with the Pi 5. It has a small little OLED display, which will be pretty cool for displaying some stats and stuff. It does have a GPIO extender, so you can still use the I/O pins even when it's in the case. Very important for us, it does have the NVMe M.2 adapter, so we can use those sorts of storage. It does have an active cooling CPU heatsink, which is great. RGB, which as we know, will increase performance at least by 10% from the RGB alone. Infrared controller, infrared receiver, which I'm not actually sure what that does, but we'll have a look. And has robust build quality. And that's kind of it really, some more statistics around the other side. Now in terms of what I had already got out of this box, so in reverse, we have the GPIO extender board here, which will kind of extend the pins out onto the side of the case. We have the CPU fan itself, which I have noticed is a little bit broken, a little bit damaged up. It will be fine. It's going to still do all right. These are very, 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 very thin fins, so it's nothing super fancy. But considering the kind of thermal output that we have, I think this will be more than enough. We have a little breakout board to convert the power pins on the actual Pi to what we have for our power button. We have a micro SD card extender riser, if you like, which will then obviously expose that to the side of the case for us to be able to still use micro SD cards. We have this little sheet, which I think is probably our OLED screen, looking at it. We have our RGB fans, which are unfortunately just standard power, so I think you won't be able to control the RGB itself, which is a shame, but still, it'll look cool, I'm sure. We have our M.2 adapter that takes that PCIe lane and converts it into use for M.2 cards. our power button and a couple of meshes for the fans. All the kind of screws and rivets and risers and stuff we're going to need. A couple of more kind of components. There's some thermal pads in there and a few other bits and pieces that I'm sure we'll need. And this, which is our acrylic side panel with its kind of protection sheets on the side, so still. And then other stuff that is in here, we've got this kind of HDMI adapter, so it takes those terrible micro HDMI ports and exposes them as full-size HDMI ports. Very, very thankful for that. Some more bits of acrylic. The funniest looking wrench I've ever seen. I'm not really sure why that amuses me so much, but there's just such a different size there. But yeah, there's that. And then the case itself, which I will say immediately feels very nice. It's metal, it's pretty sturdy, doesn't flex particularly. Yeah, this is a really nice build. I like kind of all that milled in the side there. There's the front. Yeah, this seems really nice. So the other thing I didn't show was this leaflet, which basically gives you kind of all the contents and is also the instructions that we'll be following. So let's get this put together and I'll see you on the other side. And that is everything put together. It is now a few days later. Unfortunately, ran out of time for the day, but we are back and ready to check out the newly upgraded Raspberry Pi. But before we do that, a quick word from today's sponsor, all of you. Yes, everything I needed for this video has been paid for by YouTube adverts and ad revenue. So thank you very much to every single one of you for watching this video and watching my other videos and helping to contribute to this channel the channel's growth and being able to continue making weird and wonderful videos. All right, let's get on with it. So first things first, we needed to get some additional software installed from the SunFounder website. This was to basically enable the small front screen and do some other things around fan controlling and all that sort of jazz. It was all available on their website. It's basically just a Python module, if you like. So downloaded all that, got that all installed, quick reboot, and the screen is up and running with its default configuration, which I quite like. It shows the temperature, CPU percentage, and a few other bits and pieces, which, yeah, it's just kind of a cool little thing to have on the front there, I think. And then we went about copying over our SD card onto the M.2 drive so we could boot from that. I did, of course, notice while we were copying those files over that we were already a lot cooler. The CPU at idle is kind of sitting around 30 degrees, which is probably only about 5-10 degrees more than the room temperature, which is very impressive. And even when we were getting up to kind of high CPU usage, we were maxing out at about 50 degrees, much better than that 80 degrees in thermal throttling. So once the contents of the SD card was copied over to the M.2 drive, removed the SD card, rebooted the system, and we were booting off that M.2 drive. Nothing else had to be done. A very smooth process indeed. With that very chilly temperatures now being achieved, of course that does mean that we need to overclock this system. The Pi is quite a capable overclocking machine, to be honest. There's a lot of headroom that is left on the table, partly because you do need a good thermal solution to achieve those temperatures, and that isn't included by default. So, you know, having a default clock speed anything higher than 2.4 was kind of pointless, because even at 2.4, if you try and do that across the cores, you're going to hit thermal throttling. With all that in mind, I managed to do a little bit of overclocking on the system. I found that 3.1 gigahertz on the CPU was a good stable temperature, a good stable speed, and it kept the system very stable, and also pushed the GPU up to 1 gigahertz as well, or 1000 megahertz. So that seems to be where things are stable for me. It is a little bit of a silicon lottery. I've definitely seen reports online of people being able to push it further and put other people not being able to get that kind of high speed. I don't know if the 16 gigabyte version is a bit more stable in that regards, but for me, 3.1 worked very, very well indeed. So naturally, the first thing we did is look back at those synthetic benchmarks, running Geekbench again, and we got a single core score of 1073, a very nice upgrade indeed. And then we got a multi-core score of 2255, which again seems a little bit odd. It's less than I would be expecting, but I think actually what we're getting here is we're hitting kind of voltage limits on this chip. My understanding is that it's kind of hard locked in terms of how much voltage you can push through it. So even though we can achieve 3.1 gigahertz on a single core, trying to do that across all cores isn't working as well. I might be wrong there. Let me comment down below if you have any other theories, but that's my kind of current theory at least. So then we checked out the read and write speeds of that SSD. We definitely wanted to see if we were getting a better outcome compared to the SD card, and we certainly were. We had write speeds of 343 megabytes a second, and we had read speeds of 473 megabytes per second. Now those speeds are not breaking any records, that's for sure, and the SSD in question is definitely capable of a lot faster, but what we are dealing with here is the fact that we have only got a single PCIe lane, and my understanding is it's PCIe 2 as well, so we are definitely limited there. However, it's way faster than any SD card can achieve, and also, of course, it's just generally a better storage medium. I think it's going to have much more longevity that way. You can get some very nice, up to 4 terabytes easily, maybe even 8 terabytes in that kind of form factor. So all in all, it's kind of a better way to go if you're going to try and build this into an actual computer. And then we hit back up with Minecraft. And this is a little disappointing, I will say. I was expecting better results here. We did get a few more FPS, a little bit more performance here, but it just wasn't quite getting where I was hoping it would in terms of playability. I did find if I'd lowered some of the settings, reduced things to a little less graphically intensive, and loading a little bit less at once with the chunks, we could get a playable 20 to 30 frames per second. So that's still kind of cool. That's still quite impressive considering what we're running it on. But I was hoping for a lot more, in all honesty. And that's kind of all the gaming we did on this. Obviously, we could do some emulation on here. I did also try installing Steam. Unfortunately, there isn't an ARM version of Steam, so you have to use Box86 to run it and essentially emulate the x86 environment. And it just wasn't particularly smooth, even just the launcher itself. I did find that Half-Life 1 ran all right, but then again, that will run on the potato, so it wasn't really worth any kind of metrics. I also couldn't actually get any kind of on-screen FPS working either in Steam or using something like Mango HUD. It wouldn't work. So kind of scrapped that test because at least for now, it's not something I can fairly test. But we will probably do a video in the future around gaming specifically. One thing I was impressed with was YouTube streaming. That was absolutely fine. We were achieving a solid 1080p at 60 FPS, no problem at all. I was just very happy with that. Unfortunately, when I was recording this, there was no sound, but it was working fine. So I'm happy with that. Definitely as a streaming machine, this would work quite well. That leads me to the question that I asked at the beginning of this video. Is this a desktop replacement? And I would say, for me personally, no, it is not. But there is definitely a lot more power here than in previous generations. And we're definitely reaching that point where, depending on your requirements for a desktop PC, this could actually meet those requirements. You can do YouTube streaming and video streaming perfectly fine. You can definitely do web browsing, no problem at all. Some very light gaming works, and especially if you want to get into the kind of emulation stuff, I'm sure it works very well. So in many ways, this could. For me personally, not really. We're not there yet. I definitely will be looking at different ways that I could utilize this, though, in my home. I think this would make a really interesting addition to my home server. I'm not sure what I'm going to run on it yet, of course, because I only recently set up my my full home server. But considering the performance to watt usage, I really want to get this involved somewhere because, I mean, for one, this uses about 10% at idle than what my full home server uses. So kind of almost want to build a small cluster of these and see what we could do with it. But anyway, on to the actual case itself as well. I really love this case. I think this is an absolutely brilliant addition to the Raspberry Pi. If you're looking to expand it into something that is more like a desktop or is more stable as a server, it's got really good airflow. It's got really good heat management. You've got that expansion with the M.2, which is really, really useful. You definitely don't want to be running things like a server off an SD card for very long. And then also the I/O expansion, so you've got full-size HDMI ports, very useful. Just generally really, really like this. And of course the RGB is great as well. But nonetheless, I think this is a brilliant, brilliant option if you're looking for some sort of case / expansion for your Pi. And that's where we're going to leave it for today. I will say thank you very much for watching. I hope you've enjoyed this video. I've really enjoyed making it. I do love this kind of exploration of the Pi world that I'm going through. It's a lot of fun. But we are going to leave it there for today. So if you have enjoyed this video, please do make sure to hit that like button and subscribe. And I will see you again very, very soon for another video. Bye for now.